we have to be faced with this concept that technology is not value neutral. And if you think about what machine learning really is, it is the application of massive amounts of compute, rent a supercomputer in the cloud, kind of massive amounts of compute to massive amounts of data that's even deeper, creepier than ever before, because we have sensors everywhere, to achieve business ends and to optimize business outcomes. And we know just how good businesses are at capturing and self-regulating about externalities, right, to their business outcomes. So just as a human looking at this, I would say, wow, I've got a chance to actually speak to this practitioner crowd about if you're doing your job well, you'll be forced to drive a lot of conversations about ethics and the practice of your thing, about what you're doing within your business as it goes through this data transformation. And you should be ready for that. Steel yourself for that. Don't punt. Don't punt on it. We can't afford to punt.
You're listening to Gradient Descent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Biewald. Peter Wang is the co-founder, CEO, and creator of Anaconda. He's been developing commercial scientific computing and visualization software for over 15 years. He created the PyData community and conferences and devotes his time and energy to growing the Python data science community and teaching Python at conferences around the world. Couldn't be more excited to talk to him. So, maybe for starters, I guess I know of you because of your product Conda, which I've used for many years. I have a feeling most of the people listening to this will know what Conda is, but maybe could you describe it in your words just to make sure we're all on the same page here?
Yeah, so Conda is a package manager that we built as part of the overall Anaconda Python distribution. And it started as a way just to get people package updates of the binary builds that we do. And it's expanded to then, manage virtual environments. So we could have different versions of libraries and different, in fact, versions of Python in user land, on any of the platforms we support. And then we also created a space for people to upload their own packages. And so that's Conda, that's the anaconda.org service. Around that, a community has grown up called Conda Forge, where they make recipes, maintain recipes, upload packages. But lots of other people, like the NVIDIA folks or like PyTorch, they will upload their own official builds into the anaconda.org system. So we run all of that infrastructure. We pay the bills for the CDN and for all the storage and everything. And then we do have a community around the Conda package manager itself, so people making tools and extensions for it. So that's in a nutshell what Conda is. So you can think of it as like an RPM or something like that, but primarily for data science and numerical oriented computing.
And what's your original background? Like, were you always making software, running a successful software company?
No, I've always been programming pretty much since I was like I think 8 years old. I've been programming in something, but I ended up going to college for physics, and so I graduated with a degree in physics, and I decided to join kind of the .com kind of boom by going and joining a startup, and I've been in software ever since then. But I spent a number of years working in consulting using the scientific Python and the Python stack in the 2000s, and that's really where I started seeing the possibilities for using Python for a broader set of data analysis use cases than just kind of sort of niche scientific and engineering computing kinds of use cases.
Cool. And can you explain to me kind of what was going on that you started this project and like what the original conception was when it began?
Yeah, sure. Well, the original conception, so the company was called Continuum Analytics. I started that with my co-founder, Travis Oliphant, who is the creator of NumPy and one of the co-founders of SciPy. And we put the company together to promote the use of Python and to advance the state of the art for Python for a broader set of data analysis needs. So that was the original vision. And at that time, this was 2012, we formed the company. Wes McKinney had just really started pushing Pandas as a data frame library. The Jupyter Notebook was relatively new at the time. It was still called the IPython Notebook. And the world was sort of awash in Hadoop big data craze. And what we could see was that once people threw all their data in Hadoop, they wanted to do bigger analyses. They wanted to do broader, more cross data set, cross schema sort of analyses, and they would need tools like Python. SQL wasn't going to do it for them. And so we were putting this stuff together. We were trying to find alternative MapReduce frameworks that were nicer to Python than Hadoop. And the rest of kind of the Apache Java JVM big data stack, if you will, that the JVM world does not play with the Python C++ native world very well. So in any case, as we're looking at doing all this stuff, it became clear to me that if people couldn't install SciPy and Matplotlib and IPython, they were not going to be able to install any newfangled compiler tools we built or any newfangled MapReduce framework. It was just going to be completely off the table. So we started by saying, well, you know what, we should probably produce a special collection of packages, a distribution of Python that helps people get started, that includes all of the basic things they need, that works on Mac, Windows, Linux. And so that was the basic idea. So we built Anaconda. I came up with the name because it's Python for big data, so it's a big snake, kind of.
Nice.
Although, of course, I don't like snakes that much, and Python is, of course, named after Monty Python, but whatever, we'll ignore that. So that's where the name Anaconda came from for that product. And then that just took off like quite well. And so we eventually renamed the company Continuum to Anaconda because we'd be at conferences and they'd say, you know, where are you from? Or like, or, you know, what company are you with? And we say, we're with Continuum. And say, okay, yeah, that's nice. And we say, well, you know, we make this thing called Anaconda. And they say, oh, we use Anaconda. We love Anaconda. And so we're like, after that happens, like the 1,000th time, you sort of figure out the world's telling you something. So anyway, but anyway, that's the journey. And since then, we've continued to push like new open source tools and things like that in the Python kind of data stack. So
it's incredible the impact that I think you've had, and certainly, you know, NumPy and SciPy in terms of just making Python a popular product. Do you ever regret choosing Python for this? Has that been a good choice for you?
Oh, no. That was completely intentional. I mean, we a thing that people should understand, I think, especially as more software engineers move into ML and become ML engineers, right? For them, language is just a choice. It's like, well, I'm a C++ coder now, and I learned some Go, and now I'm doing Python. It's like whatever, right? And Python's got some warts, and it's got some good things, but the thing to recognize is that Travis and I, when we started this, the reason why we wanted to push Python was because of the democratization and the accessibility of it. When you're a software developer, you learn new languages all the time because that's part of your gig. If you're not a software developer, if you're a subject matter expert or a domain expert in some other field, let's say you're a geneticist, or let's say you're a policymaker or whoever, right? You're an astrophysicist. Learning a new software programming language is hard. You're not really a coder anyway. You had to learn some Fortran or C++ or MATLAB in grad school, but like otherwise, you're not doing this like on a weekend just because you love it, right? So if you learn a language, this is going to stick with you for a while. And if we, as people who make languages or who make software tools, if we can find a language that people like to use and is powerful for them, and that multiple different kinds of people can use, that's incredibly powerful. So one of the things about Python is that the creator of Python, Guido, before Python, he was working on a project called Computer Programming for Everyone. And so some of the ideas that went to Python came from that precursor language called ABC. And that readability counts and that like kind of executable pseudocode thing, the same things that make Python hard to optimize, right? They make it consternation for statically typed language aficionados. Those things also make it incredibly accessible to lots of people. And when we make these kinds of advanced tools available, accessible to lots of people, what we do is we grow the universe of possible innovations. So for me, it's very intentional that we chose Python. It's there's 1,000 new languages you could create that are better than Python in all these different dimensions. But at the end of the day, Python is kind of a language everyone uses, right? And it's valuable that everyone uses that same language. So I have a very, very strong opinion about the fact that that we should continue promoting its use and growing its use, even as I fundamentally believe there must be a better language out there, right? That's like the successor to it. I have some ideas about that as well. So.
Oh, interesting. Yeah. I'd love to hear about that because, we were talking with the FastAI, one of the FastAI founders, Jeremy Howard, and, he's written so much Python code and he was really emphatic when I was talking to him on this same podcast about, Python can't possibly be the future of scientific computing. And I was kind of surprised. I mean, I would say my perspective is definitely a non-expert, but I really enjoy programming in Python. And maybe it's hard for me to really see how things could be better, or maybe, I don't have to kind of worry about performance as much as other people. But what would your take be? Like, is there any kind of language with less adoption that you think is really intriguing and could kind of replace Python, or are there tweaks to Python that you'd like to see? How do you think about that?
So yes and no. So like there are languages out there that do interesting things, that are things that Python can't quite do, or that Python may never be able to do. Right. So one of the fastest database systems out there is a thing called KDB, and the language in it, K. You're not going to find any. It comes from like the APL roots, right, which are the precursors to like the Fortran stuff, and then MATLAB and NumPy and all these things. So you're in any kind of algol and modula derived kind of imperative programming language, you're not going to meet the kinds of raw numerical performance that like K and KDB can achieve. And the creator of K and KDB has a new thing that he's building called Shakti, which is even more interesting. So there's that kind of lineage of things, right? There's sort of like the most out there amazing bits of Lisp plus like Fortran, and you get something like that. And Python is not there, but Python has a lot of the good parts of the ideas there and expresses them in a infix imperative language. Then there's things like Julia that do whole program optimization.
Mm-hmm. Let me make sure I understood what you said about K and other ones like it. Yeah. What's the advantage there? That they have the potential to be faster?
It's more than just faster. It's a fast and correct and performant representation of your idea, but you have to sort of warp your brain a little bit to thinking in that way. So Ken Iverson, the creator of APL, which is kind of the root of all of this stuff, he had this idea that notation is a tool of thought. So if you really want to help people think better and faster and more correct all at the same time, you need better notations. And so if you ever go and look at a bit of K, it looks different, let's just put it that way, than what you are mostly used to in like a NumPy or a Python or even a C++ or C or Java world. It's completely different, comes from a different brain space.
Interesting.
But there's
Can you
something
say
like
a little
that.
more, like, is that just because it's sort of following different conventions, or is there something to this perspective? Because I feel like every so often, not in many years, but in grad school I used to occasionally run across Fortran, and it would just be like, okay, I'm stopping here, like I'm not going to go any deeper. This just feels impenetrable to me. But is that my fault, or is that like is there something there that's like better about it, I guess, in the notation?
Well, better is a big word. So
Sure.
I'll back up and say like the difference between something like K or fourth or J, kind of like J, K, fourth, APL versus Algol or like Pascal, C, kind of this lineage of fairly imperative procedural languages. At the end of the day, we are programming. When we write a program, we're sort of meeting. We're making a balance of three things, right? There's the expression itself, like what it is we're trying to express, like, there's the data, the representation of the data, and then there's like some compute system that's able to compute on that data. And so I call this kind of the iron triangle of programming, is that you've got expressions and expressivity or expressiveness, you have data schemas, data correctness, things like that, and then you've got the compute, which is runtime, again, correctness, runtime characteristics. And every programming system sits somewhere in the middle of this like ternary chart, right? And usually you trade off. What happens is usually collapse one axis onto the other, and you have a linear trade-off. Mm-hmm. And most of the post-Nicholas Wirth kind of era of like looking at, okay, you've got data, you've got a virtual machine, and you're going to basically load data in and do things to it with functions that proceed like this. That model is sort of what everyone has in their heads as a programming system, right? When you look at something like Forth or like K, you actually come from a different perspective. So Forth, I'll throw that in there because even when you do have an explicit data representation in mind, when you write programs in Forth, or if you ever had an HP calculator, reverse Polish notation, it's probably the closest that most people will ever get to Forth, you're explicitly manipulating stacks. You're explicitly manipulating these things, and you're writing tiny programs that can do a lot. It's amazing, right? And that's with an explicit stack and explicit these kinds of things. When you go to something like Lisp or like K, you're writing these conceptual things, these expressions. In the case of Lisp, it's a conceptual algorithm. In the case of K, it's also an algorithm, but it's an algorithm on parallelizable data structures, on arrays and on vectors. And then you can, a part of your first class thing that you can do is you can change the structure of those data structures. You can do fold operators. You can apply in these ways. You can broadcast and collapse and project. And all of those are first class little things you can do in line as you're trying to express something else. So you end up with a line of K that's this long that would take you, a page of Java to do. And by the way, the genius of the K system is that the underlying machine that interprets that, the compiler and then the interpreter system, is incredibly mathematically elegant. Because there's actually fundamental algebra that you can sit in the heart of this stuff that you can then, basically K will load into, I think the claim is that it loads into L1 iCache. And so your program just streams through the CPU like a mofo. Like it just, you're never even hitting L2, right? So that's kind of an amazing thing. And so I think when you turn around, you look at something like Python, which is like not that optimized at all. It's like the C-based virtual machine. But when we do NumPy things, you're expressing some of those same ideas, right? So
yeah, I was going to say this reminds me of my experience with NumPy where, I keep kind of making it tighter and tighter and shorter and more elegant. But then when I need to debug it, I feel like I often end up just unpacking the whole thing again. And I don't know if that's like me being stupid, but that's definitely my process.
Well, it depends on what you're debugging though, right? Because you can make it compact. And then when you debug it, it's like, are you debugging a mismatch, an actual bug in the runtime of NumPy itself? Are you debugging a performance mismatch with your expectation relative to how the data structure is laid out in memory? Are you debugging a impedance mismatch between your understanding of what NumPy is going to do in each of these steps versus what it's, there's a lot of things to debug, so to speak. But that's one of the downsides of making really tight NumPy snippets. Because I did some of that back in the day, and it was like, oh, this is so great. And then something blows up, and it's like, oh, crap.
But wait, I'm like taking off on all these tangents, and I'm actually really fascinated by,
this is the conversation.
Totally. But so you were saying, so you're comparing to K, which actually Jeremy Howard did talk about and really, really praised.
Great.
But then what are the other kind of languages that have like interesting pieces that could be useful for scientific computing?
Yes. Well, I think so Jim Gray, the late great Jim Gray, wrote an amazing paper back in 2005 called Scientific Computing in the Coming Decade. It was prescient. It was ahead of its time, I think. I mean, it was at Jim's time, so he knew it, but he was writing this great paper, and it talked about how so many different things he talks about in this paper. It's worth everyone to read it. But he talked about how we would need to have computational sort of notebooks, how we need to have metadata indices over large data that would have to live in data centers that we couldn't move anymore. We'd have to do computing. We have to move ideas to code. Move code to data, move ideas to data. All these different things. But one of the things he explores is, why don't scientists use databases, right? Databases is the realm of like business apps and like Oracle nerds. Why don't geneticists and astrophysicists use databases? The closest they get is using HDF5, right? Which is really just like, it's a file system. Great. It's a tarball, right? It's a tarball that lays out in memory so you can compute on it. So that's great. You can do out-of-core execution on it. But why don't scientists use databases more? And so he kind of looked into this a little bit more. But one of the things I think that would really move scientific computing forward is to treat the data side of the problem as being more than just fast arrays. And actually, as we have more and more sensor systems that have more and more computational machinery to get to additional data sets, which then become transformed into additional data sets, that entire data provenance pipeline, even as businesses have to reinvent the enterprise data warehouse to do machine learning on all their business data, I think scientific computing has to honestly sit down and face this giant problem it's tried to ignore for a very long time, which is, how do we actually make sense of our data? Not just some, like /home/ some grad student's name /temp /project 5 whatever. Like, we've got to actually do this for reals, right? So I think one of the ways to move scientific computing forward, that is on the completely opposite side of like going to the K land and fast APL land, is treating data, the metadata problem and the data catalog problem, and in fact the schema and semantics problem, as a first-class problem for scientific computing. So if you look at what F# did with type providers and building a nice extensible catalog of schema that was actually part of your coding as you were using data sets, they did that in like 10 years ago. That stuff is amazing, right? And that is something that we should make available. That's something that would be that would be a game changer. I don't know if you saw this thing where some like internet council of like geneticists, they declared they would change actually gene names. Did you hear about this?
No,
they
no.
changed. There were gene names they changed from March 1, Sept 1, and things like that because bioinformaticians use Excel so much, and when those show up in Excel data, Excel translates them into dates, and it screws them up. So because of Excel's auto formatting of their things, they're literally changing the names of these genes. This is how depraved science has gotten, right? Is that we will. Not that those are necessarily great names to start with, but the fact that we will wrap ourselves around a fairly broken tool for this purpose. I don't know. That's so for me, handling the data and schema problem for science, like full stop, that's a huge part of the problem that needs to be done. Yeah.
That's so interesting. Is that something you're working on?
No. I have a company to run. Like we're gonna make money. We're gonna make money, and no. But if when we get to a certain point where we have the resources to invest in additional projects, then this is one of the ones that I would absolutely try to tackle. We do have a project that's kind of in this vein. It's called Intake. It's not the sexiest sounding thing in the world, but Intake is a virtual data catalog that lets you set up a data server. So if you set up an Intake server over here near your data, and you fire up the client just in your terminal or in your notebook or whatever, you can connect to it, and you can basically you hit it with like remote pandas and Dask calls and things like that. And you can also create transformed, almost like materialized views of those things on the server. So it's been used in a few projects. Some people are starting to pick it up, but it's something I would recommend people check out. It's called Intake.
Cool. All right, we'll put a link to it.
Yeah.
Do you? So can you give me some examples of who your customers are and what's the value? This is like such business speak. What's the value that they get out of your company?
So we have a couple of different things that we sell. For a while now, we've been selling a enterprise machine learning platform called Anaconda Enterprise, and that has it's based on Kubernetes, and data scientists can IT can stand it up. Data scientists log into it, and they have a managed, governed notebook environment. Well, any number of different UIs, but generally people prefer notebook environments. And then they have one-click deploy for dashboards, for like notebooks and things like that. They can run machine learning models and have REST endpoints they deploy. It's sort of like it's a big data science platform thing. There's another thing we sell that is just the package server. So a lot of the value that businesses get from us is that they have a actual vendor-backed place to get binaries to run like in their governed environments, which actually does matter to them, right? And so in that situation, what they want to do is they have like a server, they buy a server from us that has the packages, and then it's proxied locally for them. We don't get to see all the packages they're downloading, what they're doing with their data analysis, and they also have faster access to all of these different packages. Their IT people, this is a really important thing, IT has a chance then to also govern which clusters, which machines, and which environments can use which versions of which libraries, right? Which is a really important thing, because in an enterprise environment, you have data scientists who want the latest and greatest and bleeding edge everything, and then you've got production machines, which you do not want getting the latest and greatest of everything. You want to know exactly which version, how many CVEs, which ones are patched, and that's all that runs in production, right? So this is a package server that gives businesses the ability to do that. So those are primarily our two commercial products, and we'll be coming up with some more things later in the year. It's an individual commercial edition that individual practitioners can buy, things like that. So,
and you've been doing this a while, right? Like at least a decade.
Not a decade. An octal decade. I mean, we started in 2012. So, yeah.
Nice. I guess like what even that is quite a long time, I think, for this space. I'm curious, like when you started, what kinds of customers or like what industries are using you the most, and how has that changed over the last 8 years?
Yeah, when we started, it was very heavily in the finance, so hedge funds, investment banks, things like that. There was a heavy use of Python there at the time, and we were doing a lot of consulting and training, open source consulting, standard sort of things like that. Unlike a lot of nowadays, you see a lot of these open source, venture-backed open source companies that have like a product, and it's like, here's our open source foobar, and here's the enterprise foobar++, right? And then Amazon builds a clone of it off their open source, and they go public anyway, make tons of money. This is a play that many companies have done, especially around some of the big data infrastructure projects, right? It's a pretty popular move. We are an open source company that supports an ecosystem of innovation. So there's a lot of things that are out there that we deliver and ship via Anaconda that we ourselves don't write. And so that innovation space has changed, and it's gotten sucked into so many different things. So now we've seen everybody. I mean, insurance, oil and gas, logistics, DoD, and three-letter agencies, and just like everybody is using Python to do data analysis and machine learning. So it's just literally everywhere, like sports betting sites, Netflix and the Ubers of the world, like everybody is doing this stuff. Now, not all of them are paying us yet, as paying customers, but that diversification of, well, I wouldn't say diversification, but that growth and adoption was what we were hoping to unleash, right, when we started the company. And so it's been really great to see all that happening. We couldn't have predicted deep learning. We couldn't have predicted that machine learning would have been the thing to take off. We were really thinking that it would be more rapid dashboards around notebooks, around building. Here's a data analysis. I'm a subject matter expert because I can write a little bit of Python code. I now can produce a much more meaningful, rich interactive dashboard and control pane for my business processes or for my heavy industrial machinery. We saw that happening pretty well in the 2000s around a rich client tool set as sort of a MATLAB displacer. But now with machine learning on the rise, it's completely flipped Python usage into a different mode. That's as you would know at Weights and Biases, that's the dominant conversation around Python. But these other use cases are still there. There's still a lot of people using Python for all these engineering simulation things. And so anyway, it's just been great to see all this growth and diversification of use cases.
Is machine learning even the top use case that you see? I feel like it's certainly it feels like the buzziest right now, but I always wonder what's the reality of the usage volumes versus
it's
what you see
the
on the ground.
aspiration that people get paid for. Put it that way. I think there's a strong disconnect between older businesses. I would say Python has crossed the chasm, right? So you talk about the chasm of technology and crossing the chasm. Python has crossed the chasm. On the other side of the chasm, the way that this kind of innovative technology has landed is that you have a lot of buyers who are not as sophisticated about what it is they really want to buy or what it is they're buying or how ready they are as a business to adopt what they've bought. Okay? So you can buy the fanciest Ferrari, but if you have a dirt track road, it's not going to go as fast as if you have an actual smooth paved road. So a lot of businesses have this problem where they can buy the hottest, sweetest ML gear, team, tooling, blah, blah, blah. But then their internal data is just a mishmash. And so you spend 80% of your time digging that ML team out of the data swamp, right? So that message, I think people are starting to get it now as they come to, over into the chasm of the trough of what not despair, something, yeah.
Disillusionment.
Sad. Disillusionment. Disillusionment. That's what it is. That one. That's what it is. Right. And so, but the truth is this: it's there's an ML hierarchy of needs, just like Maslow's, right?
Right.
And if you don't have your data stuff together, if you don't understand the domain problem you're trying to solve, you have no business even doing data science on it. If you haven't done data science, there's no models to go and optimize with machine learning, right?
Right.
So, but if you get all that in place, then machine learning can absolutely deliver on the promise. So I think people try to buy the promise, but most of the people they pay are out there slugging a bunch of trying to basically denormalize data, dedupe data, and just do a lot of that kind of stuff.
But you actually see it most of the verticals that you mentioned, I think, are not the first things that come to mind here in Silicon Valley for ML applications. But
right.
You actually see insurance doing ML and thinking of it as ML, just as a specific example.
Oh, absolutely. So the hardcore finance folks are probably the only people I would say that lead Silicon Valley in terms of ML. I mean, the hedge funds were there first because they operate in a pure data environment. Mm-hmm. And the thing about that data environment is everyone else is operating in the same pure data environment. And by the way, it's all zero sum. So and if you screw up by a millisecond, you lose millions of dollars. Incredibly hard odds or hard boundary conditions to be optimizing in, right? And I think Silicon Valley, it's a lot of consumer behavior. It's a lot of this kind of thing. Certainly anything in ad tech and kind of the attention economy, the ML there is fairly low stakes, right? I would say that, of course, hundreds of billions of dollars of corporate valuation hang in the balance. But if you screw a little bit of something up, it's they'll be back tomorrow doom scrolling. So we'll give them some better content tomorrow. But when you're in insurance and these other things, the ML, those models, the kinds of diligence that a credit card company has around its models and model integrity, the kinds of actuarial work that goes into building models at an insurance company, that's real. That's like, there's real hard uncertainty. If you screw up, that's $100 million screw up, right? So there's real stuff happening there, and there are no lightweights on this stuff. They're doing real things. Yeah.
Cool. I guess when I've talked to insurance companies, it's felt like there's almost these sort of two separate teams that feel a little bit at odds with each other. Like there's sort of like the old school math guys, like the actuaries who are like, what is this? We've been doing ML forever. Like this is just a rebranding of the stuff we've always been doing.
Right.
And then a couple guys off to the side, maybe doing some crazy deep learning projects that you wonder how connected they are to the business. Like, do you feel that same dynamic? Or
what absolutely. I mean, any organization over like 50 people is a complex beast, right? So even 50 people can be pretty complex. So these larger firms, there is definitely a struggle internally as they do this data transformation into the cybernetic era, is what I've been calling it, the cybernetic era. And many of them, the theory of action is still open, right? It's like, oh, we sell this particular insurance policy, and we'll see what comes back 5 years from now, right? And when we get screwed, like we'll look at our 5-year retroactive performance, and then we'll know if the model was correct. And those kind of old guard folks who are, a bunch of actuaries writing a bunch of SAS code, that's some old school stuff. And then there are new people in that space who have access to the data, who have the statistical background, and who know they can do way better. And so there is a conversation happening. I mean, within credit card companies, you'll have, like, they're a great example, right? Because there's like regulatory pressure, there's like old school models in SAS, there's newer people trying to do some better credit models, and there's really cutting edge people doing real-time risk, real-time fraud, like all these kinds of things, using deep learning sometimes, using all sorts of GPU-based clusters. So you just see a whole pile of different things within like a credit card company. That you might not see it in Silicon Valley. It's more monoculture because there's less tech overburden that they have to like dig out from, right? There's like, well, we need a bunch of machines in the cloud. You got it, because there's no regulators checking any of this stuff. So yeah. What
do you make of like, I guess like the MATLabs and the SASs of the world? Like, is that ever like a sensible choice for someone for their tech stack, or is that just a completely legacy software choice
for de novo? Well. Let me see here. I think the best way to answer that is that anytime we make a technology choice, we should be very respectful of Conway's law, which is that the technology systems that we build, the software systems we build, are a reflection of the communication patterns within the teams that built it, right?
Third time that's come up this week in interviews, by the way.
Really? Yeah. Yeah. But it hits the ML stuff in a different way, which is that if those different teams speak different languages, then you have two teams. If the same team speaks two different languages, you have two teams, right? And we see this actually with people trying to get Python into ML production, where sometimes those production processes are optimized for managing a pile of Java with a bunch of Maven, right? Or it's like you got to recode all in C++ because we only deploy TensorFlow C++. So there's this kind of thing. When you have a language barrier, you create two technology fiefdoms, which then lead to a bimodal or trimodal or whatever kind of software product. And an ML system is a software product, however you want to look at it. It fundamentally has a pile of software in it. So when we talk about this question of like, is MATLAB or SAS ever an appropriate choice? The answer is, well, obviously yes, because the whole team knows MATLAB or SAS and they're building this, then you should probably use MATLAB or SAS, like even for brand new projects starting tomorrow. However, the question then is taking a step back. If I'm the manager of this team, how much longer do I want to only have a team that only knows how to use MATLAB or SAS, when clearly all the papers at ICML or whatever are being published in Python, right? So like, you got to sort of make that call if you're the manager. So I would say that the answer is yes, but if you're doing that, you should be aware that there's all this innovation happening in different languages. And even if you bring those languages into a hybrid environment, if you say, fine, I'll hybridize. I got my legacy MATLAB that's never going away because that's how we modeled like airflow through this turbine system. I'm not going to redo all that work. But then I have to build discipline about how to hybridize, how to bring these people forward so they know some Python, bring the Python technology back to be able to couple with the MATLAB, and see yourself as having to become an expert in doing that, right? Mm-hmm. So I think that's the answer is yes. That would be my answer. Yes, you could absolutely make a justification for starting new projects and those things. But generally, if you're doing it in teams that already know those languages, I probably wouldn't recommend it for a Python team.
What about R? Like, where does that sit? Is that ever like a reasonable choice for a team where you have greenfield or
yeah, of course,
or not?
No, of course. I mean, there's lots of people who do that.
And what would be going on that you would choose to use R versus Python?
Well, for me, because I'm a Python expert, I would choose Python. So the only reason I would have my team use R is if there's a lot of existing stuff that's in R, or they're all R experts, in which case I'm not going to try to convert them to Python. I'm going to try to make the best go of R with them, right? But if there are really new capabilities and things that are only available in like a Python bridge to some CPU or some GPU stuff, then I would encourage that I would have to hire in some people who are polyglot that can build that bridge. So again, it comes down to the teams.
Although I feel like you do, I don't think you really have the perspective that like kind of all languages are created equal, right? I mean, of course, we hit
No.
like the real world and we have to choose our language maybe around what library is available or like what's going to be maintainable. But I'm curious what you kind of make of R. I mean, when I was in grad school, I used all R and I absolutely loved it. And then I had this experience of like, kind of seeing Pandas and NumPy and just be like, "Whoa, this is way better!" Like, I just want to switch to this and use this.
Well, some people take the opposite position from you on that. They would say, "I went to R, and now I can think like a statistician again, and actually do my, express what I'm trying." Because like the tidyverse and dplyr and these things are so nice, and ggplot's gorgeous, and all these things.
Yeah, that's true.
A lot of the R advocates, they have good good points. Like there is I would say a more monoculture is the wrong term. There's a smaller set of obvious choices in R, and if you've used those and the team around you uses those, you can get to very nice results without a whole lot of like people tearing their hair out because they have conflicting versions of like 15 different plotting libraries like we have in the Python land, right? So, so anyway, so yeah, I don't know. Of course, I don't think all languages are created equal. But you did ask me a question, which is there ever reason to do these different languages? And I said yes. There's always a reason to use these other languages.
That was probably a poorly formed question. I was giving you too many outs.
You're giving me an out for sure.
A CEO of a company that wants to sell software, I know you don't want to take too hard of a position.
Well, Anaconda does support R. I will point out, Anaconda does support R and R packages managed within the Conda environment. So you can actually manage, and one of the things that we're doing is actually looking at the precise versions and building the dependency graph. So if you want to go in and you don't want to just take a whole snapshot, like a whole CRAN snapshot, and you want to say, well, what if I want to use this version of this thing, but that version of that thing, I just want to upgrade that. Can I do it? So we're using a Conda approach to package management for the R ecosystem as well. And that's what's happening in conjunction with the Conda Forge folks. That's been building out. Now we have coverage of several thousand libraries in the R universe too. So
well, awesome.
Yeah,
it's interesting. Okay, here's the question I really want to ask you. I'm just going to ask.
Go for it.
Go
for it.
This might be dumb, but I guess the one thing that I really felt when I switched from R to Python is like, man, the graphing libraries are worse. And I hope I don't offend anyone with that comment. And I feel like I've never. I feel like NumPy has improved so much, and SciPy seems to have like so many libraries that anything that I would want is like not a super deep scientist. I feel like it used to feel like Python or R had way more packages to cover my needs, and it feels like Python's kind of catching up there. But it sort of feels to me like the graphing libraries are still kind of frustrating. Is that because I'm misusing them, or is there a library out there that I should know about?
No, the graphing libraries in Python are awesome, and it's clearly the user's fault. So I don't know what you're talking about.
There's just one user.
No. It's a common complaint. I think what happens in Python there is that if one were to take a sort of a more objective look at all these, as the author of like 2 or 3 different, not the only author, but the originator, let's say, of 2 or 3 of the graphing libraries in Python, and now there's several dozen, right? There have been. What we have here is a couple of different things going on. So R does what R does very well, precisely because it was designed by a user community for that community. So, and also because of its sort of Lispy heritage, it is able to do some really neat tricks by preserving kind of the transformation pipeline and kind of coding the expressions, things like that give you some really awesome superpowers when you're building. Like, just give me a facet of like these things, and it's like it just does the right thing, right? Obviously, I mean, also Hadley did great work with ggplot too. Like, there's nothing, not to say there wasn't hard work involved there, but then if you want to go and do some additional, if you want to do plots outside of some of the things that ggplot is great for, then it's a more impoverished landscape, let's say, right? If you want to do real-time spectrograms there in R, I don't know, man. Like that's, or if you want to do like really large-scale interactive web graphics with like all this like crazy map data,
True.
I don't know. It's sort of like, so the Python
Yeah.
world has always been more multi. It's just been, there's a lot more Mongols across a bigger plane, and so there's just many different flavors, different things all over the place. And Matplotlib was written by a guy in grad school trying to plot EEG plots, right? And then he moved on to a hedge fund, but then he was trying to copy what he knew, which was MATLAB. And it does great for that, actually. If you're an engineering MATLAB user, Matplotlib works great. Like, you just fits your brain, right? But most like, ML people were not MATLAB people, right? And then likewise, if you use tools like Seaborn, they get you kind of some of the way there, but then they don't have the support from the language level to encapsulate some of the statistical transformations that would help inform something even better. So it has to sort of include some of those transformations within it, right? Facets, names, things like that. So then you go around and you look at some of the interactive plotting systems, whether it's Altair, whether it's like Bokeh or any of these other things, Plotly, then they all are solving for kinds of different parts of the problem. And to do as much of a cover of the Python use cases is just bigger than any kind of project was able to do. I think there's more compact set of use cases in R, and so therefore it was possible to do a higher level of cover in a single project. Does that make sense?
Totally, yeah. That's really well said.
Thanks.
And very non-judgmental. I love your
We're all about Big Ten. Anaconda, it's all about the Big Ten, right?
Big Ten,
it's all about the Big
totally.
Ten.
Yeah. You do packages. No,
We do
not playing favorites.
Not playing favorites.
So okay, we always end with two questions, and I want to make sure I get them in because I'm curious to hear your thoughts. So, so one question that we always ask people, and maybe I should ask this in a more expansive way. What we always ask people is there a topic in ML that doesn't get as much attention as you think it should, that people should focus on more than they do? And I might expand that for you into like all of scientific computing. Like what's the things that people aren't, or what's one thing that you think people don't pay as much attention to as its usefulness would suggest?
I think a topic, there's lots of topics. My general thing stems in, it comes from this place where I feel very strongly that ML practitioners, more so than just software like coder nerds, are going to run into the ethical implications of their work. And even more uncomfortably, they're going to be the ones forcing that conversation in businesses that for a long time maybe have not had to think about that. Because ML is about engineering the crown jewels of the business models. So you're like, hey, we just figured out this way. If we buy these two data sets and do this kind of model and reject these kinds of people from our user base, we get this kind of lift. Should we do it? Well, it's like, heck, I mean, I'm just a VP of God knows what. I didn't ask to be presented this incredibly difficult trolley problem. Like, don't look at me, right? I slept through that crap in college, So I think that ML, more than any other thing right now, we have to be faced with this concept that technology is not value neutral. And if you think about what machine learning really is, it is the application of massive amounts of compute, rent a supercomputer in the cloud, kind of massive amounts of compute to massive amounts of data that's even deeper and creepier than ever before because we have sensors everywhere, to achieve business ends and to optimize business outcomes. And we know just how good businesses are at capturing and self-regulating about externalities, right, to their business outcomes. So just as a human looking at this, I would say, wow, I've got a chance to actually speak to this practitioner crowd about if you're doing your job well, you'll be forced to drive a lot of conversations about ethics and the practice of your thing about what you're doing within your business as it goes through this data transformation. And you should be ready for that. Steel yourself for that. Don't punt. Don't punt on it. We can't afford to punt.
Besides stealing yourself for that, which is probably a good verb for that, do you have any suggestions on how someone might educate themselves in that? Because I think we have a lot of people listening to this that's in that situation that might be wondering, where could I find more resources? Do you have any suggestions? Yes.
So I think there's books that have been written now, especially in the era of like the Facebook and information attention economy sort of dystopia stuff. There are a lot of there's books by Shoshana Zuboff, Kathy O'Neill, Weapons of Math Destruction. There are books like even like I think Christian Rudder, Dataclysm, right, and some of these other things. You can look at arm yourself with knowledge about the anti-patterns of what happens when ML blindly applied goes wrong. And that at least gives you a bit of a war chest of like, or a quiver of things you can reach for to say, what we're doing here is exactly like what happened when, I just pull one out of the hat, like when AOL anonymized their user data, or it was AOL or AT&T anonymized their user data back in the early 2000s. And they did this anonymous data release and this thing happened and somebody got outed. Like there's all sorts of wonderful examples you can pull from because we've actually been making a lot of mistakes. So one thing is take the time to read about that stuff. Number two is go to and attend talks about sort of this quote unquote, this soft topic about ethics in ML and fairness and whatnot. I know some of it may seem a bit sermony and preachy. It's like, hey, I came here for like the hardcore convnets. I didn't come here to go listen to somebody drone on about ethics. But in every conference you go to and everything you go and do, spend some time getting educated about the state of the art thinking. Because right now people are trying to think about preserving privacy, preserving encryption, and some of these like these things, differential privacy. Those things are coming. Those are going to be part of like the state of the art best practice soon. You should be educated about those things and not only just do it because you have to, but know why. Because I guarantee you, when you go and scope those into your project, some VP is going to come and say, well, can't you just get rid of that and do it faster? And you have to be able to argue the principles of why you need to do it this way, right? So that would be the one thing I would say is, I don't know if it gets maybe already too much press, but it probably doesn't get enough press, is that the ML practitioners, if they're not going to be just serfs in this, if they actually want to have agency in that conversation and hold their own ground in what we should do and not have a pile of regret down the road, then now is the time to start getting educated and start asserting yourselves more in those internal corporate political discussions.
Awesome. Well said. Ooh, take a deep breath. Final question.
All right, final question.
When you look at companies trying to get stuff into production, what are the surprising bottlenecks that they run into? Like when somebody's trying to take an ML project from like, kind of an idea to deployed and it's working and doing something useful, where do you see people get stuck?
Oh, well, every part of the process can be troublesome. I don't know if there's a surprise there at all. I guess one thing that's surprising to me is how many corporate IT places are still pretty backwards relative to open source. This was surprising to me in 2014. It's still surprising now how many places will say, well, we don't really do open source, or here's the open source that we do. It's just these few things. And then when they say that, they trot out all the tired FUD arguments about how can we trust this thing, how can we trust that. The other thing is that there is still a very strong Python allergy and a lot of lack of awareness of what Python actually is and can do. And so there are some companies that are like, well, this is a Java shop or this is a .NET shop. We really only know how to deploy these ways. We don't deploy Python. You have to recode that because it's just a language. You can recode this other thing, right? Why wouldn't you be able to? And these IT shops, they don't understand that when you use Python, you're harnessing, like you're linking into like seriously optimized low-level code that a lot of seriously smart people have been doing. And there's not the equivalent over in the Java space. And all the data marshaling back and forth is going to cost you a tremendous amount of performance in the Java space, right? And these IT shops have not yet understood that. And sadly, a lot of the ML engineers, they are relatively new and they don't know how to articulate that argument. They don't know how to sit there and talk about JVM internals and all these other bits because that's not their gig, right? So I think that's been sort of the depressing. It's surprising that it's still this issue because we do have companies that deploy Python in frontline production stuff to do some of these ML things, and they're fine. And even with that as proof points, there's still kind of these industry inertia. Yeah.
I mean, what would you even use for like a non-open source machine learning framework? This shows you how sort of maybe Silicon Valley Kool-Aid I've become, but.
No, I think what ends up happening, to be honest, they'll buy some vendor thing, which still just embeds the machine learning, the same open source machine learning thing. No, I kid you not. Like that's literally what they will do sometimes. It is if you get into corporate IT enough, like it gets pretty depressing about the kinds of like the incentives are all messed up there, unfortunately, which is one of the reasons why Silicon Valley does run circles around some of these other companies. Yeah. Yeah.
Man, we should have ended on your ethics answer. This is just impressive. I guess both are kind of worrying in different ways.
We have our work cut out for us. We have our work cut out for us. That's for sure.
Nice. That's a good way of putting it. Thanks so much. That was really fun.
Yeah. No, thank you.
When we first started making these videos, we didn't know if anyone would be interested or want to see them, but we made them for fun. And we started off by making videos that would teach people. And now we get these great interviews with real industry practitioners. And I love making this available to the whole world so everyone can watch these things for free. The more feedback you give us, the better stuff we can produce. So please subscribe, leave a comment, engage with us. We really appreciate it.